so we wrote these on yesterday. Hopefully, if you're using the 2-column note system, hopefully you got them ready to go. If you're not, that's fine. But you're going to need the rules and the practice. So, did we do any of them? We can start fresh. All right, so first off, some words that you need to know. A subscript, sub means low. So a low script are like these 3s, 2s, 5s. All the little numbers are subscripts. You okay with that so far? Never, ever change a subscript when you're balancing a reaction. We cannot change this to like a 3 to make it work out. That changes the compound, and that's not what we're doing. We're changing the amount of stuff, not what the stuff is. It's like you ran out of eggs on your cookie recipe. You can't just substitute another cup of flour. Like, you have to replace the eggs with eggs, right? So we can't change the substance. We can change how much of the substance there is, though. Okay, so that's this first thing. Start with the highest subscript that is not part of a polyatomic ion. So like if we look right here, that 3 belongs to NO3. So we would not start with the 3. We would start with the 2 because it's not part of the polyatomic ion. That's what this rule is telling us. Okay, rule 3, and they're not rules, I keep saying it, but they're just tips to save you time. It says leave polyatomic ions together if they are on both sides of the arrow. What that means is if you see like PO4 on one side and PO4 on the other, then don't balance P and don't balance O separately. That's a waste of time. Balance the PO4 together. How's that idea? You all right with that? If you look at this problem, though, PO4 is on one side, but there is no PO4 over here. So this one, you do have to balance the P and the O independently. We only use this if they are on both sides of the arrow. Okay, then the last, well, I guess there's 2 because I wrote another one. Write water as HOH if hydroxide is on the other side of the arrow. So if you look up here, water is right here. It is written as HOH in this problem because over here is hydroxide. But if you look at the problem right down here, water is written as H2O, and that's because hydroxide is not on this other side. This little nugget right here will make a lot of hard problems very easy. Now, as part of this, please, oh, that's the wrong button. Oh, that was the right button. Please realize that sometimes we are going to refer to water as a 2-part substance where it has one H and one OH. Meaning, occasionally, we are going to treat water as though it only has one H. Right. All right. The reason that we're going to do that is so that you can realize that these parts, where'd they go? Like right here, there's 2 H's. There are not 2 H's here. There's one, and then there's an OH. If you treat it that way, life gets a ton easier. All right, and then this one. When in doubt, start with the metal. And we're going to use that sometimes. We may not use it other times, but if there's a tie and both of the highest subscripts are the same, start with the metal. That will usually solve your problem a lot faster than starting with O's or H's. Okay, so let's get into this. So what we will do to balance a reaction is we will add what we call coefficients, which means that we're going to change the amount of things on each side, but never the identity. So I'm going to rewrite this real quick. It's Al2O3, and it goes to Al plus O2. These are the reactants. These are the products. When we balance a reaction, we literally have to make sure that the reactants are equal to the products. What we mean by that is our reactants right now consist of 2 ALs and 3 oxygens. My products only have 1 AL and 2 oxygens. So if I put this on a scale, it would not be balanced. This side would have more mass, right? But the masses have to be equal. So we can fix this by adding numbers over here to balance it out. So I'm going to use the idea of the first time-saving tip, that is, you start with the highest number that is not part of a polyatomic ion. Now, I skipped one on accident. This weird one, it's a little sentence I wrote. If you see a 3 and 2, you should use the swaparoo. You will actually use this ridiculous statement a lot more than you think. The swaparoo says, and we can use it right here on this first one, it says, if you see a 3 and a 2, and they have to be on the same substance, like oxygen, you do the swaparoo. So look right here. What that means is you take the 3 and you put it in front of the thing that has a 2. And you take the 2 and put it in front of the thing that has a 3. Now, there's a very mathematical reason that I'm doing that. Over here you had a 3 that had to equal a 2. 3 never equals 2, but if you multiply 3 by 2 and 2 by 3, they now equal 6, right? That's what I did here. I took 2 times 3 to get 6. I took 3 times 2 and got 6, and 6 and 6 equal each other. Okay, now, I'm not done yet, because in balancing, when we fix something, we oftentimes screw something else up. So we fixed the oxygen, but the aluminums, now there are 4 of them, and there's only 1 over here, right? So what do I need to put right here? A 4. So this reaction, when it is balanced, is 2Al2O3 goes to 4 aluminum plus 3 oxygen. All right. This process is a really logical process that this one doesn't usually take very long to click. Once it does, some of you will actually enjoy doing this. All right. Looking at the second one, Mg plus HNO3 goes to MgNO32 plus H2. So we're going to follow these suggestions and try and get this done as efficiently as possible. So the first thing that we'll point out on this is that there is, I guess, one polyatomic ion, but it is on both sides of the arrow. So I'm going to use this. I'm going to leave the NO3 together and just balance it as one thing. There's an NO3 on the left, there's 2 on the right. All right, now I go hunting for the highest subscript, not part of a polyatomic ion, and it is this 2 or this 2. And it doesn't matter which one I start with, because when I fix either one, it fixes the other. So let's just look at H's. But you could do it the other way, it doesn't matter. If I have 2 H's on the right side, what do I need to put right here? A 2. And then I got to fix what that screws up. That takes care of the H's. How many NO3s did it make? 2. But we have 2. So the last thing would just be to check 1 Mg and 1 Mg, and that is done. 1, 2, 1, 1. They're not too hard. there's some hard ones coming up, but this is not that bad of a process. Okay, let's do number 3 together. So once again, water is written as HOH here, so you realize it's an H and it's an OH. Two separate things. So here we go. The highest subscript is this H. So if I have 2 H's on the right, I need 2 H's on the left. And I know it looks like there's 2, but there's not. There's 1 H and 1 OH. So what do I need to put right here? A 2. And that's going to screw a lot of stuff up. How many OHs does that make? 2. So what do I need right here? A 2. But that screws up the K's. There's now 2 on the right, so how many on the left? 2. Now, putting this 2, did that affect anything else? No. So I'm probably done. And I only had one other blank. That's where I started, so I was done. 2, 2, 2, 1. Now, do not try the next one on your own. And we're going to skip it for a while. Hopefully this hour I actually remember to come back to it because I forgot last hour. Yeah, this one has its own set of rules because they are much harder. Okay. So, will you come here and try that one on your own? You were probably right, Boyd, I think. Whatever you just said. Let me see. Yep. Good job. All right. When you have AG plus S goes to AG2S balance, will you raise your hand? Okay. We'll give you about 30 more seconds. This one hopefully is pretty simple. The only subscript you have is a 2 right there. There's only 1 AG over here. Can I put a 2 right here? The answer is no. We cannot change subscripts. If I put a 2 there, that means silver is diatomic, which it is not. But I can double the amount of silver. All right? Then I check sulfur. There's a 1 and a 1. They're not written, but they're implied. So that's already balanced. So it's just 2, 1, 1. Okay, this next one is significantly harder than all the rest of them we've done so far. All right, this one, apply this little sentence I wrote right here. When in doubt, start with the metal, and I'll give you a good solid minute to do that one. This one, in the long run, is not that bad. If you do this. This makes it easier. So here we go. You come along and you have polyatomic ions. We're going to leave them together because they are on both sides. So we look for the highest number not part of a polyatomic ion. And there's a 3 there and there's a 3 there. You can start with either one, but one of them is significantly easier to start with, and that is the metal. So, right, I have 3 calciums on the right side of the arrow. So how many do I need over here? 3. So I put a 3 right here. And then I fix everything that screws up. What is 3 times 2? That's 6. So how many OHs do I need over here? 6. How many H's does that make? 6. So what do I need in front of this 3? A 2. What does that do to the PO4? Makes it a 2, but that's dandy because I already have a 2. So I put a 1, 3, 2, 1, 6. Who had that right? Good. Now, if you're not raising your hand, don't panic. That one is hard. So you can relax. All right. Will you do this one on your own? That should be a lot easier compared to what we just barely did. So we wish life was as easy as this one is. There's 2 BRs, so you got to double the amount of lithium bromide. That means you have 2 lithiums now, so you have to double the amount of lithium, and you have 1 bromine. 2, 1, 2. Okay? Will you try this one? If we're on like a 1 to 5 scale of difficulty, this would be a 1. This would be like a 2 or a 2.5, and this would be like a 4. So that kind of gives you whatever. Until I teach you how to do these are usually 5s, even though these two boys rocked it. All right, here we go. This one, we have 2 ALs, we have 3 O's. So rule number 1, I would follow that you start with the highest subscript. If you start with the metal, both of them work fine. Like either one of these two, you will be just fine on this problem. So if I have 3 O's, I'm going to put a 3 right here. That makes 3 FEs, so I need to put a 3 right here. Then I got to come back, I check my aluminum. There's 2 on the right, but only 1 on the left, so I put a 2, and then I am done. 2, 3, 1, 3. How many had that right? Raise your hands. That is awesome. Awesome, awesome. Good job, guys. A lot of times kids, you haven't asked yet, they ask, do you need to put a 1? Technically, no. But I would get in the habit of putting a 1, because a lot of times you'll just have like one number up here. This was the only 2, and you may look later and not think you're done. Or it might be a test where this is a point, this is a point, that's a point, and that's a point, and you wouldn't just leave 3/4 of them blank. So just get in the habit of putting the 1s. Okay, this one's like a 4 until you see it, and then it's a 1. Try that for a second. Okay. Typically, this style of problem is the hardest. And what I mean by this style, when a polyatomic ion is not on both sides, life gets a little bit trickier. When that happens, we have to treat everything individually. So we have 3 CAs, we have 2 Ps, we have 8 O's. Okay, we have to balance them individually. If you use rule number 1, you would start with the O's. Not rule, suggestion number 1. I would not do that personally, because if you try and balance O's, you'll notice it's in 2 separate places, and that can be tricky. Now, you can, and it's fine. I would personally start with the metal, and either way is fine. If you start with calcium, there's 3 of them, so you got to put a 3 right here. And what does that do to oxygen? There's now 3 oxygens, but it's in 2 places, so plus how many more? 5, and that equals 8, which is a very good feeling because it needs to equal 8. So oxygen is taken care of, calcium is taken care of, so I just check phosphorus is 2, and I'm done. So it's 3, 1, 1. Now, just quickly, if you chose 8 oxygens, it's fine. It just looks a little harder because you have 5 and 1 more, so you think you have 6, and how do those equal? Well, they're in 2 different places, so you triple the O here, and that makes 3 plus 5, and then you have your 8, and you're there also. So both of them work just fine. It's just sometimes harder to see when you try and balance one thing that's in 2 places. Okay, the bell's going to ring soon. This one's not too bad. It has a ton of polyatomic ions. You can start with that 2 or that 2, and it will not matter. Please, over the weekend, make sure you have read all of Chapter 2. If you're still struggling with naming or formula writing, watch those videos that's on the screen right there on Chapter 2 on Canvas. And then we're in Chapter 3, so please read those first 2 sections.